friends, this is Narsimha. Today I am going to describing about the dissolution instrument and its mechanism. Okay, what is the dissolution? Why you have to perform the dissolution in a pharma industry? Okay, here you can see that this is the dissolution instrument. Dissolution instruments is like this, not a fixed, but it is a just for example I am telling. Okay, as per USP General Chapter 711. It is totally describing about the dissolution mechanism and its operators. What are the operators are there in as per USP? It will describe about the USP General Chapter 711. As per USP General Chapter, dissolution operators having 7 types. There are 7 types of dissolution operators are there, like basket, paddle, reciprocating cylinders, flow through cell, and rotating cylinders disc, paddle disc, like that. So as per USP, 7 types of dissolution operators are there. Okay, and different pharmacopoeias having different type of operators. And as per EP and IP having 2 types only, paddle and basket. And BP also having same category like paddle and basket. Mainly we are focusing on the USP that are having 7 types of operators. Okay, first of all, we have to know the what is dissolution. Dissolution is a process in which the drug from the solid stage to converting into it's a granulation. After that, granulation is dissolving into the solvent. Mainly here, 2 steps are there in a dissolution procedure. First step, from the solid stage, the drug converting into the granulation stage. After that granulation, total it is dissolving in a solvent. Okay, that procedure will be happening here. Okay, I will describe one by one here first. In dissolution instrument, mainly we have to see here. This is the water bath, and this is the these are the vessels. Like these vessels, 6 vessels are will get in each dissolution instrument. And water bath. This is the water bath. Okay. See here, first of all, here some fixed parameters are there. Different pharmacopoeias having different parameters are they fixed for the different type of drugs. Okay. For example, this water bath will be used for the maintaining of the temperature. In all dissolution instruments may be probably the temperature of the water bath is 37 degrees. Okay, because it is the temperature of how we are maintaining in our stomach, same thing will be reflecting here. That is why it's called as a in vitro procedure, because this is totally we are observing in the outside. So this is called in vitro procedure, and if it is happening in our body means in vivo procedure. Okay, here some fixed parameters are there in a dissolution analysis. One is temperature, one is RPM, and one is operators. Okay. Temperature. We have to maintain the temperature during the analysis 37. There is a tolerance limit for the temperature is that 37 plus or minus 0.5 degrees. You can tolerate the temperature up to plus or minus 0.5 degrees only. You should maintain the temperature 37 degrees for the during the analysis. And RPM. This RPM also it is depending on the drug. Different drugs having different RPM for the different pharmacopoeias. So you can tolerate this RPM also plus or minus 4%. And operators. Operators also it's depend on the pharmacopoeia and the drug. Like either you can use the basket, either you can use the paddle, you can use the and the reciprocating cylinders. Okay. Mainly all of the drugs you are using by the paddles only. Paddles. When you are using the basket, the tablet is flow movement. Which tablet is having the flow movement that can be used by the basket, because you have to hold the tablet at a fixed stage. That is the reason we are using the basket apparatus during the dissolution analysis. Okay, so here we are poured the water and we are maintain the temperature of 37 degrees during the analysis. After reaching the temperature, and we have poured the buffer in each vessel as a 900 ml. Either it is the phosphate buffer or 0.1 normal HCl. Okay, you can pour the buffer in each vessel of 6 vessels, and after that you can add the tablet in a vessel. If it is normal tablet means you can use the apparatus as a pedal. If it is a flowing tablet means if you are adding the tablet, it can move here and there. There is a no fixed place. It is a very delicate tablet. That is the reason it is moving from here to there. In that situation, you have to use the basket apparatus for the analysis, because we are using basket means we have to keeping the tablet in that basket and it will fix like this. So it will dissolving in a vessel as a without disturbing any abnormality. Okay, here the main concept of this dissolution is we have to identify the percentage of active drug releasing into the solvent. It can be identified by the UV or HPLC. Okay, this in vitro procedure is totally non-sink condition. What is that? This is a non-sink condition, because after some time the water the drug releasing into the same vessel, it will get saturate, because we are pouring the 900 ml of buffer in each vessel. Okay, after some time, maybe it is after half an hour, after 45 minutes, after 1 hour, the totally drug dissolving into the this particular vessel only, and this vessel whatever buffer we are added, that buffer will get saturated. There is no chance to dissolve more drug into the this solvent, because this is called a non-sink condition, because there is no chance to move here and there. If in our stomach, it is called a sink condition, because we are taking the tablet and it is dissolving in our stomach, and the particles are going into the blood cells. Continuous process, because it will move all the body at all sides. There is no chance to stop the particular place, because in our stomach it is called a sink condition, and it is called this dissolution vessel and dissolution mechanism is called a non-sink condition, because there is a limited solution only in this vessel. Okay, after completing the complete dissolving of the tablet, you have to take the buffer solution, means you have to collect the sample from each vessel, and you have to measure what is the percentage of drug released in a particular time, in a specified time. You have to identify that percentage. Here this percentage of also having here 3 stages are there in each dissolution analysis. One is S1. S1 means whatever the active ingredient was dissolved in a particular vessel, and it is identified by through the UV. That percentage is having different pharmacopy having different types. So here S1 stage is all vessels will get the Q plus or minus 5%. If all the 6 vessels results are obtained above the Q plus 5%, it has meet S1. If any vessel, any means in 6 balls we are getting the any one ball less than the Q plus 5, it is go to the stage 2. Okay, here we have to know about the Q. What is the Q? Q is the how much percentage of active ingredient was dissolved in a specific pharmacopoeia. That is called a Q. Okay, if you are not getting the any one of bowl from the 6 vessels, it will goes to S2. In S2 we have to perform the 6 more tablets. Okay, Here the results of S1 plus S2, all 12 balls is greater than or equal to the Q. Whatever mentioned the Q, that result should be matched, it is more than the Q of the 6 plus 6. Means 12 balls result should be greater than or equal to Q, or one or no more unit was not less than the Q minus 15%. No more unit means should not be less than 1 unit also Q minus 15. If any ball got the results Q minus 15, it is go to the stage 3. In stage 3 you have to perform with 12 tablets. Means in stage 1 6 tablets, and stage 2 also you have to perform the 6 tablets, means 12 tablets, and here stage 3 you have to perform 12 more tablets. So totally 24 tablets you have to perform. The average of the 24 balls should be greater than or equal to Q, and no more 2 units you can tolerate that. Q minus 15% you can tolerate 2 units, and no more units were not less than the Q minus 25%. Okay, these are the stages in a dissolution apparatus: S1 stage, S2 stage, S3 stage. S1 stage 6 units you have to perform. All results should be Q plus greater than or equal to Q plus 5%. In S1 stage, any one of unit was not meeting in the criteria of Q plus 5%, it is goes to stage 2. Here you have to perform the 6 more balls. All the 12 units should equal to Q, and no more unit should not be Q minus 15%. And S3, if one unit also not meeting in the criteria of Q minus 15%, it is goes to Q3 stage 3. Here stage 3 you have to perform the 12 more units. Here the average of the 24 units should be matched with the Q, and there is a tolerance limit like that 2 units are Q minus 15% and no unit not less than the Q minus 25%. This is the dissolution criteria. Mainly this dissolution having 2 types. One is the drug is converting to the granulation, means it is a disintegration. How much time requirement to the solid form to granulation form, it is called disintegration. Here dissolution we have to one more step, that granulation is converting into the solvent stage. Okay, after this drug is dissolving in the particular vessel, it is saturating the solution, means the graph will be like this. There is a no more dissolving will happening in the vessel. Okay, this is the time, and this is solubility. See, some starting time it is the dissolving of the tablet is going to higher side. After some time it will get the saturate. So this is the mechanism of the dissolution. In this way the procedure will happening, and this is the way for the dissolution apparatus and mechanism. Thank you.